for any basic exponential function, the characteristics for every single one of them is going to be the same, unless there's transformations applied in that function. And we'll get to that later in another video. But for now, we're going to go back to the same two examples we had in the previous video when we were learning how to graph exponential functions. We're going to look at these two examples. And if I look onto this graph and I'm trying to figure out my domain, I know that means moving from this side to this side. And when I do that, I can see my graph goes all the way from negative infinity to positive infinity on the x-axis. But when I'm gonna look at this bottom graph too. It's the same. It goes from negative infinity to positive infinity. And that's true for every exponential function. The domain is going to be negative infinity to positive infinity. Okay, but now let's look at the range as well. So the range is going from the bottom to the top. So from the bottom, I have an asymptote at y equals 0. And my graph will never touch that x-axis and it will never cross. So when y is equal to 0, my horizontal asymptote right there is exclusive of my range. It's not included because it's never going to touch that line. And it goes from 0 to infinity. Same with my bottom one. It goes from 0 to infinity. So for my range, for any basic exponential function graph that doesn't have any transformations, my range is going to be 0 to infinity, and both of these are exclusive. That's why I'm using my round brackets. So I have a horizontal asymptote on both of these graphs, and for a basic exponential function graph that has no transformations, I'm going to have a horizontal asymptote when y is equal to 0. So whenever y is equal to 0, I'm going to have a horizontal asymptote, unless there's transformations. So my horizontal asymptote is at y equals 0. And if we look at both of these graphs, they have one point in common. This graph had a point of 0 and 1. This graph also had a point of 0 and 1. And that is true for any exponential function. It's going to have a common point of 0 and 1, every single exponential function. But 0 and 1 may be transformed. But in a basic exponential function where there's no transformations, there's always going to be a common point of 0 and 1. So you have a common point of 0 and 1. And the last thing we're going to look at is an increasing function. Increasing function. And we're also going to look at a decreasing function. Okay. If we look at something here, for our first example, our a value, which was 2, was greater than 0 because 2 is greater than 0. And when our a value was greater than 0, we noticed that as our x values increased, oh, I made a mistake right here that I didn't notice before. This should be a negative 2 and this should be a negative 1 if this is supposed to be in proper order. Okay, so as my x values increase, my y values also increase. And this was an increasing function. And that's when my a value was greater than 0. Okay, so I'm going to write that out as a rule. And I'm going to say it is an exponential function will be an increasing function when a is greater than 1. Okay, but what about our other graph down here? As our x values increased, our y values decreased, and it was a decreasing function. But if we look at something right here, our a value was less than 1. Okay, so when our a value is less than 1, it's going to be a decreasing function. Okay, I'm just going to add. So when we have our a value is in between 0 and 1, it's going to be a decreasing function. So basically when our a value is a fraction, it's going to be a decreasing function. And those are some characteristics that you should know about an exponential function, a basic exponential function graph with no transformations.